everyone. So in this video, I'm going to talk about the first part of the Fundamental Theorem of Calculus, and I'm just going to go through examples. So this is my second example video, so let's just jump right into it. So these are the examples that I'm going to compute. So you can kind of decide how you want to use this video. If there's a specific example that you want to see, you can kind of just scrub through the video and find it, or you could, watch the video just as is, or you could use this as a way to quiz yourself just to see how much you understand. So you decide what kind of makes sense for you. Okay, so let's jump into this then. So using the first part of the Fundamental Theorem of Calculus, I need to take the derivative of this. This is about as straightforward as you can possibly get. So I'll just restate the Fundamental Theorem of Calculus part 1. So I have a whole video where I break down what all of this means and kind of how we arrive on this. But the key thing I need to do this problem is kind of this last line here. And so really what you're looking for are your limits of integration. So as long as you have a number here and x here, you're basically good to go. And then you can kind of just plug in the x. That's kind of giving you permission to do that. So in this case, like I said, this one's pretty easy peasy in that I can just, if I take the derivative of this is just going to be the square root of 3x plus 2. Boom, done. Nothing else to do because this is just an x right here. Okay, so now let's take a look at some other cases maybe where that doesn't happen. So notice, so with this one, so I've got x, but if I compare it to the Fundamental Theorem of Calculus, it's kind of like in the wrong position. So basically now we have to use what we know about definite integrals so that I can mess with these limits of integration. Oops, sorry. So if I want the x to be on top, which I do, then really what I need to do is rewrite this. So I'll put a negative in front, and then I can flip my limits of integration, and now I can use my Fundamental Theorem of Calculus. So now if I want to take the derivative of this, that means that dy dx equals negative sine x, done. Okay, so now let's move on to the next one. So now I not only have my limits of integration flipped, but this is not x, this is sine of x. So really the way that we view this then is this is kind of like a composition of functions. So we're actually going to be using kind of the chain rule here. So why don't we first just flip all of this once again, just because I prefer having the x on top. And now I can go ahead and evaluate this. So I have dy dx, this will equal negative 3. So I'm going to go ahead and plug in, no, not x anymore, but sine of x. I'm going to plug this sine of x into the t spot. So this becomes sine squared t, but now I'm really using the chain rule here, so now I have to take the derivative of this function. So the derivative of sine is cosine. And so that's really my answer. If I maybe want to make this look nicer, I mean, there's, oops, and sorry, this was not t, this was x, my bad. It should be x. So this times cosine of x. Okay, and so there you have it. And so I have one more here. So same idea. So once again, I have, so at least this time the x is kind of where I want it. It's on the top part, or in the upper limit of integration. So now I'm going to plug this straight in. So I take dy dx. So I plug this into where my t is. So this becomes 3e to the 4x plus 1, but now I have to multiply this by the derivative. Now, this actually I'm going to have to use a chain rule also on this. So the derivative of e is just e, and then I leave the inside function intact, and then I multiply that by the derivative of 4x, which is just 4. So in the end, this equals 4e to the 4x over the square root of 3e to the 4x plus 1, and we're done. And so that was a nice and short and sweet video. So if you're looking for more explanation on this, if this doesn't totally make sense to you, I have lots of other videos on this, so I highly recommend you check those out. This was just a straight up video to plow through a bunch of examples, and so I'm kind of assuming you kind of understand some of those pieces. So if you're feeling a little unsure, go for it and check out some of those other videos. Otherwise, thanks for watching.